Alright, so that was the end of the front side of the assignment. So this is continuing on with the solutions for the review for Mastery Quiz 12, which is all about vectors and doing things with vectors. On the back side, we got a few things that we're doing, such as transforming the vector using a given matrix, and then describe the transformation, I'm guessing, in words. So I'm going to take this vector and times by this matrix here. So something to remember, this number is getting times by these top numbers, and this one's getting times by the bottom ones. And then you're adding those products together like so. And that's going to give you your resulting vector. So I'm going to get v prime, I guess you can call it. Well, you have to do 2 times the negative 3. The negative 2 times negative 3 gives you positive 6. And we got the 4 times the negative 3 down there. That's going to give me negative 12. And that's the whole vector. And this one, since my numbers got bigger, that's definitely going to be a dilation. And the dilation is what number you're multiplying by. And we just multiplied by a single number, negative 3. So we dilate by a factor of negative 3. And on 19, we have our lovely vector here, and we're timesing by both those guys there. The 1 gets times by the 2, the 8 gets times by the negative 2. If you're lost on what that process is about, go to the transformations assignment, and I give a further explanation there. So 1 times the 2 is going to be 2, 8 times the negative 2 is going to give me negative 16. And so this one is a dilation by a factor of 2, but it also includes a sign change on the y component, which is going to be a reflection. If you have a sign change of just one of them, and you kept the same order, it's going to be a reflection. So it's a reflection over, let's see, we change all the y's, that's a reflection over the not the y-axis, the x-axis. So that's our transformations on those. These other two, and you take these numbers, and notice how the main diagonal has zeros. That means we're going to have to take these and change the order, and then multiply this way. This one's still getting times by the bottom number, this one by the top one, but we need to switch the order of the products. So this is going to go first. So negative 4 times negative 6 gives me positive 24. And then the negative 3 times the 6 over there is going to be negative 18. And when you change the order, you change the sign on one of them. That is a 90-degree rotation. And I notice I started out at negative, and I went to positive, negative. That's going from the third quadrant to the fourth quadrant, which would be a counterclockwise rotation. And it's also got a dilation by a factor of 6. So this one has a couple of transformations going on between those two. And then on 20, we got to take these, and notice again they're switched, so we have to change the order of these, where they're at, and we're multiplying that away. The negative 2 gets times by the positive 1, which is going to be negative 2, and then 5 times the negative 1 gives you negative 5. If you start out at this, which is in the fourth quadrant, and you get here, and that's in the third quadrant, that is a 90-degree clockwise rotation. And there's no dilation on this one, just times by 1, change the order, change the sign on one of them, would be clockwise. And then this next one, we need to determine what matrix was used to get the current transformation and describe the transformation. So it's got a couple of things. So something I always make sure, you're going to have zeros either down the main diagonal or the other way. Once again, if you have zeros this way, you're going to keep the same order. If you have zeros this way, you have to change the order. So right now I notice I got 2, negative 1, and negative 2, negative 1. So my order is staying the same, so I can have zeros this way, and the opposite of the main diagonal. My main diagonal is going to have numbers in it. I go from 2 to negative 2, that means I have to times by negative 1 there. And I go from negative 1 to negative 1, which means I have to times by 1 there. And that one is just going to be a reflection over one of my axes. Let's see if I start it. Oh, the x's are changing signs, which means I'm changing which side my x's are on. And that's going to be a reflection over the y-axis. Not y-axis. This is a reflection over the y-axis. And on 23, again, get my 2x2 matrix ready to go. I have 9, -1, -9, 1. My order stays the same, so I get no zeros this way. I went from +9 to -9. So that's times by -1. From -1 to 1, that means that's times by -1 again. Changing the sign on both of the coordinates is equivalent to a 180-degree rotation. And that brings us to the next section. Again, get my matrix ready. I went from 2, 8 to 8, 2, so I had to change the order, so I'm going to have zeros this way. The 2 gets times by this number down here, and it stayed the same sign, so we're going to have that be 1. And this one went from 8 to -8, so I have to take 8 and times by -1. So that's my my matrix for transformation, for the transformation, and that one is going to be a 90-degree counterclockwise rotation. You might want to write down some of the things so that you know what type of transformation is going on. 24, we started out -3, -5, -5, 3, so there was a order change, so we can have zeros down this way. -5 got times by this number, and ended up -5 again, so that's going to be 1. And -1 is going to take the -3 times by -1, gives you +3, so there's a sign change there, and that's the exact same thing, and that's a 90-degree counterclockwise. Oh wait, just kidding. That's not counterclockwise, that's clockwise rotation. I was thinking it wrong in my head. So clockwise rotation, not this counterclockwise business. Yeah, so I had to go from positive, positive. So that went from the first, no, that went from the first quadrant to the second quadrant. So that's counterclockwise. And this one went from the third quadrant to the second quadrant. That'd be clockwise. Hold on a second. I want to see what I did wrong. It's actually with these up here on the signs on these. So these are both 1, but the 2 gets times by this top one. The 8 gets times by the bottom one. And so this bottom one should be negative. And that fixes the issue with the matrices. Anyway, so there you go. Counterclockwise, clockwise, 90-degree rotations. And that brings us to the next one. We need to get the determinant of the area of the figure. This one, it gives you 3 vertices, which means it's a triangle. And so to get the area of a triangle, you're going to get the determinant of a matrix made up with the coordinates of the points, and then a column of rows here on the right side. So we get 7, 2, 8, -7, and then column 1, 0 on the right side. So you determine that. And once you get the determinant, you have to get the absolute value. And since it's a triangle, you're going to get 1/2 of that, and that gives you your whole thing. Well, if you get the determinant, you get this number here on the right side, which is why I had it there already, because it's kind of tedious putting it in the calculator. So I got that. It comes out to be -146. Well, you need to get the absolute value of -146, and you need to get 1/2 of that absolute value. Absolute value makes it positive, so that's 146. Half of 146 is going to be 73, and there we go. Moving on to 26, I know I told you guys how to do this, but if you happen to remember, there's a few ways you can do it. Way that I found the easiest way is, well, one, we have to assume it's a parallelogram. So I'm just going to assume it's a parallelogram. And then you just pick 3 points, and you get the determinant using those 3 points. And then you get the absolute value of that, and you're good to go. And that's it, you're done. There's no cutting in half. So you get -7, -3, 1, -1, 1, 1, and 10, -2, 1. And when you get the determinant of that, you get -62, but the absolute value of -62 is +62, and that's going to be my end result. On this one, again, I'm going to use these 3 coordinates here to make out my matrix, which is going to be -4, 2, 1, -1, 5, 1, and then 2, -4, 1. Now I have those. I'm going to get the determinant of that, which happens to give me -36. You need the absolute value of the determinant, which is going to give you +36. 36. And then on 28, we have three lovely points for our vertices here. And those are negative 4, 1, 0, 4, and then 2, negative 2. And then again, use a column of 1s on the right side. Get the determinant of that matrix you just made, and then get the absolute value of that and cut it in half. The determinant is negative 30, so we have 1/2 of the absolute value of negative 30. The absolute value of negative 30 is 30. 1/2 of that gives you 15. And that's it. And that's the end of our assignment.